Okay, I am going to talk real quick before we get too far into this about this week's assignment. We are at the end of the unit, so we have the test this week. So I want to talk about what's going to be on the test. Part one of the test, of course, is the multiple choice section. So that's going to have lots of factoring. This is a factoring unit, right? So this is all about factoring. So there's going to be a bunch of multiple choice questions. Let me see if I can see how many questions are on there. 14 multiple choice questions. 14 multiple choice questions on part one. And it's all about factoring the greatest common factor, kind of like I was talking about this quiz. All right. We're talking about the quiz. On the test, talks about finding factoring out the greatest common factor. So you factor out the 2 or the 2x or the 3y or whatever factors out. Multiple choice. Factor the greatest common factor. Identify the factors. So this is where you have to factor it out. Factor completely. Determine the factors of this. Factor completely. What are the factors of this? Determine which is a perfect square trinomial. That would mean you have the same binomial twice. The factors are the same, like x plus 2 times x plus 2. That's the same factor. So that means those are being squared to create a perfect square trinomial. So you have to identify which one of these trinomials comes from a perfect square. Let's see. There's a question where a guy's building a square garden. And so what is the length of one side? It gives you the trinomial expression, which represents the area of the garden. So you've got to factor it to find out how long would each side be. If I multiply this side times this side, it would equal that trinomial. And since it's a square, these are going to be the same factors. There's another one to identify the factors of this. Here's a binomial that's been partially factored. So they give you the final equation and one of the factors, and you got to say, what is the other factor I'd multiply that by to get the final polynomial. There's one asked for the zeros of the polynomial. Make sure you understand the zeros. We'll talk about zeros here in just a moment. There's a parabola. I want to know the vertex of a parabola. So that was in one of our lessons talking about the equation to find the vertex. And then the last one is which graph represents the function. So it gives you a function and wants to know which graph represent, which you can tell by what is the y-intercept and what are the zeros. You look at the graphs and see which y-intercept and which zeros match the equation shown. So you don't have to make it too hard. In fact, all 4 of the graphs I'm looking at have a different y-intercept. So all you got to do is compare y-intercepts to the y-intercept you should have according to that function. So that is the multiple choice part of this week's test. But I want to talk about the part 2, which some people struggle more with part 2 because it requires more work. It's not multiple choice. You have to put together all the work and the answers and all of that on your own. You got to show the work and those type of things. So I'm going to go through and just talk about the types of problems we're going to see on that. There's only 3. This time there's only 3. Sometimes we have more than that, but there's only 3 this time. And let's talk about what they are. The first one will give you an expression, right? Multiple terms, probably like 4 terms, I think, and ask you to rewrite it so that the greatest common factor is factored out completely. So let me see. I got an example of one. Let me put this out there. So, for example, maybe they will give us, let me put this up on the screen for you so you can see what I'm doing. So in part 2 of the test, the first problem will have you rewrite an expression so the greatest common factor is factored completely. And let's say, for example, it gave us this right here, 2x to the third plus 10x squared plus 4x plus 20. All right, so it gave us that expression, and it says rewrite that so that the greatest common factor is factored completely. So we have to look at each term and see what can we factor out of it. First, let's look at the numbers. 2, 10, 4, and 20. What's the greatest common factor we can take out of those 4 numbers? Well, obviously 2, we can't go any bigger than 2 because that's the smallest one we have there. But if we factor 2 out, a 2 will come out of all 4 of those. So we can take a 2. How about an x? Can we take an x out of all 4 terms? X to the third, x squared, x. Oh, we do not have an x on the last term. So x cannot be factored out. It is not a greatest common factor because it has to be all the terms in order for it to be considered a greatest common factor. So 2 is it. So if we take a 2 out in the first term, that just leaves x to the third. If we take 2 out of 10x squared, that leaves 5x squared. If we take a 2 out of 4x, that just leaves a 2x. If we take a 2 out of 20 plus 10. So this would be like part A, where it has you rewrite the expression so the greatest common factor is factored completely. That's it. That's factoring out the greatest common factor, which is just a 2. Part B of this one, because there's always part B or part C, right? All these things. Rewrite the expression completely factored and show all the steps. So that means this needs to be factored further. So with 4 terms, we generally like to do grouping, factored by grouping. So let's do that. We still have our 2. Still have our 2 out there. And then let's put these as a group, x squared plus 5x squared, and then plus 2x plus 10. Okay, what can I factor out of x squared and 5x squared? I'm going to put my 2 out there. So x squared will come out of both of those, which leaves, no, is that the 5x? This is x to the 3rd. My bad. X to the 3rd. There's somebody trying to correct me on that. Don't let me get things wrong, guys. 2x to the 3rd, when we take out a 2, we end up with x to the 3rd. All right. So x to the 3rd plus 5x squared. We can pull the x squared out of there because that's the largest out of there. When we pull x squared out of x to the 3rd, that just leaves an x. We pull an x squared out of plus 5x, that leaves a 5. Okay, so that's x squared times x plus 5 would give us this. Now what can we factor out of the second one? We got a plus 2x and a plus 10. We can't pull an x out because we don't have an x over here, but we can pull the 2 out. And what does that leave? That just leaves an x and plus 5. So I'm going to put this as the second. That is a plus 2. So if we look at it, both of these terms, now we're down to 2 terms, x squared times x plus 5 plus 2 times x plus 5. X plus 5 is common to both of those. So we factor it out. So now we got 2 and we got x plus 5. And when we factor out x plus 5, what's left? X squared plus 2. And x squared plus 2 cannot be factored anymore, right? Because x times x, but this 2 is just 2 times 1. This is not difference of perfect squares. It doesn't have the middle term to be able to factor that. This is as a prime polynomial. We can't factor that any further. So this is part B, which is exactly the same as this one, but it's in its entirely factored form. This is exactly the same also. It just has factored out the greatest common factor. So those are all 3 equivalent to one another. This is the original. This is with the greatest common factor. And this is completely factored. All right. So we've taken out the greatest common factor and we've factored this down to its 2 binomial factors. So that would be something like number 1 would look like. Okay. It'll have something like that, some kind of equation. Number 2, let's look at the second one. The second one will have, it'll give you a square. It won't put a drawing on the square. It just says the area of a square is, and it'll give you an example like, it'll say, okay, this square is 4x squared minus 20x plus 25. Okay, and it says that is the area of this square. So if that is the area of the square, determine the length of each side of the square by factoring this expression. Well, we know that the area of a square is the side times the side, or the length times the width, because a square is a rectangle, so length times width. But the sides are going to be the same. The length and width is exactly the same as each other. So the side times the side. So how long is a side? So we know then, if this is the area of a square, this is a perfect square trinomial, because we use the exact same binomial times itself to get that, because it's the area of a square. So since we know that, we can break this out using the perfect square trinomial factoring process, right? We look at the first one. What makes 4x squared? When we multiply the factor by itself, what makes 4x squared? Well, 2 times 2 will make 4, and x times x will make x squared. So 2x times 2x is 4x squared. The last one's a 25. So that's a perfect square of what factors? Well, it's either 5 times 5, or, don't forget the other option, -5 times -5. Either one of those will give us that 25. How do we know which one to use? It's all going to be that middle term. What is the sign? What is the sign of the middle term? Since it's a minus, these must be minus 5s. So the length, part A, what's the length of one side? That is it. One side of the square. One side of the square is 2x minus 5. All the sides of the squares. All sides of the squares. They're all 2x minus 5. It's a square. They're all the same. So knowing that that's the area, this is the length of one side. Then part B, like we said, we always have a part B, right? Part B gives you the area of a rectangle. And it'll say it is so big, factor it to tell us the dimensions of this rectangle. So let me put an example out. What if we have right here? I'm going to say my rectangle is 2x squared plus 4x minus 6. And I want to know what's the dimensions. So that means it's going to have two factors. Somehow, that's going to equal the 2x squared plus 4x minus 6. So we know it's going to be a 2x and an x. All right, that we know, 2x and an x, because that's what it's going to take to equal 2x squared. There's no other options. That we know. Now we need to figure out what these other terms are. So to do that, we are going to take the coefficient of the first and the last one. 2 times negative 6 is negative 12. What are all the different combinations that will get us to negative 12? Well, we can have 1 and negative 12. We got negative 1 and 12. We can have 2 and negative 6. We can have negative 2 and 6. We can have 3 and negative 4. We can have negative 3 and 4. And that should be it. That's all the different combinations that will get us a negative 12. So if we add these together, 1 plus a negative 12 is a negative 11. Negative 1 plus 12 is a positive 11, right? 2 minus 6 minus 4, negative 2 plus 6, positive 4. We're looking for which one equals this. Oh, it's this factor here. That means we can break this down to 2x squared. We want this one. Minus 2x plus 6x minus 6. See, this is a positive 6. So our middle term, this 4x, is going to be broken down to a negative 2x and a plus 6x, because those add together to give that 4. And they will get that negative 12 that we need by multiplying the first and last coefficients together. So now we factor by grouping. So 2x squared minus 2x. What can we pull out of there? We can pull out a 2x. What does that leave? That leaves an x. Negative 2x, factor out 2x is just minus 1. All right. And then we got a 6x minus 6. We can take a 6 out of there. Take a 6 out of the first term, leaves an x. Take a 6 out of a negative 6 minus 1. There we've got that x minus 1 again. Factor that out. And then that leaves the 2x plus 6. So that's our two factors, 2x plus 6 and x minus 1. That is the dimensions of our rectangle, which we found by factoring the trinomial. We use the factor by grouping. Go back and review the lesson if you don't remember how to do that. The lesson goes through that. There's videos on how to do that in the lesson. There's a lady in there that does it on the chalkboard. So there are examples of how to do that. But that's how we find the factors of that. So part B is this is the dimensions of the rectangle. All right, there's one more. Like I said, there's 3. The last one gives you a quadratic equation. Okay, quadratic equation. Let's see. I'm going to give you like x squared minus 4x minus 12. Okay, quadratic equation. And it'll ask you first, what are the x-intercepts of the graph? The x-intercepts. Where does it cross the x? It crosses the x when the y equals 0, right? When y equals 0, then the graph is going to be right on the x-axis. So that means we need to find the zeros of this equation. So we set it equal to 0. When does it equal 0? When does the y equal 0? This is like y equals, right? Function equals. When does it equal 0? Well, we need to factor this. All right, we need to factor this. This has the same factor, negative 12 times 1, that we just did in our last problem. But this time we got a negative 4x. Last time we had a positive 4x. So I can go back to these same factors. And this time I'm going to use the one that makes a negative 4x. All right, so I can break this to x squared plus 2x minus 6x minus 12. All right, same factors. Now when I factor out by grouping, I've got an x that comes out, and that leaves an x plus 2. Negative 6x, negative 12. Let's pull a negative 6 out of it. Negative 6 out of there leaves x. Negative 6 out of negative 12 leaves a plus 2. And it still equals 0. X plus 2 factors out of both. That leaves an x minus 6 in both terms. So here's the factors of our original quadratic equation. X plus 2 times x minus 6 equals 0. So if we multiply two numbers together, any two numbers, and multiply two numbers together, and the answer is 0, that means one of the numbers we multiplied must have been a 0. Right? There's no other way we can multiply two things together and get 0 unless one of those is a 0. Or both of those is a 0, but at least one. So the zeros, that means either x plus 2 equals 0, or x minus 6 equals 0, minus 2, x equals negative 2, or plus 6, x equals 6. These are the zeros of this equation. This is the x-intercepts. Part A, what is the x-intercepts? Right there. That is the x-intercepts. Or the zeros, also called the zeros. That's where the y equals 0. It's going to be on the x-axis. Part B says, is the vertex of your graph going to be a maximum or going to be a minimum? And what are the coordinates of the vertex? Justify, show your work, right? So the vertex, is it going to be a maximum or minimum? We have to go back to the original equation and look at the x squared term. Is this a positive or a minus? This is a positive, right? There's not a minus out there. So with parabolas, when you graph a quadratic equation, it's either going to make a parabola that goes like that, or it's going to make a parabola that goes like that, right? It's either up or it's down. It depends. If it's a positive quadratic, it goes that way. If it's a negative quadratic, it goes that way. This is a positive quadratic because the x squared term is positive. So it's going to look like this, which means the vertex, which is the turning point of the parabola, is going to be at the bottom. It's going to be a minimum for ours. It's going to be a minimum. It's going to be the smallest point. The lowest value that it goes to is the vertex. Could be the maximum if it was a negative, but ours is a positive. And it says, what is the coordinate? Well, first we got to figure out what is the x value, which is where the line of symmetry is. The line of symmetry cuts that vertex exactly in half. Right? The left side's going to look just like the right side, like a mirror. Line of symmetry. And we find that by negative b over 2a. What do you mean b's and a's? I don't have b's and a's. Well, remember, a quadratic equation is written down as ax squared plus bx plus c. That's the standard form of a quadratic equation. Our a is just 1, right? Our b is negative 4. So our axis of symmetry is x equals negative 4 is going to be a positive 4 over 2 times 1 is just 2. So x equals 2 is our line of symmetry. That's the line of symmetry, which also means the vertex, the lowest point, goes to where the x is 2, because that is that line of symmetry. But we need the y. A vertex is a point. It's an x, y coordinate. We need a point. Well, if the x is 2, let's just put 2 into our equation. 2 squared minus 4 times 2 minus 12. What's that equal? We know the x is supposed to be 2. 2 squared is 4. Negative 4 minus 2 is negative 8 minus 12. 4 minus 8 is negative 4 minus 12 more, negative 16. So our vertex is going to be at 2, negative 16. That's the point. That's the lowest point of our parabola. Part C. This one has a C. What are the steps you would use to graph it? So we have to list the steps. You write that out. First, I would do this. Then I would do this, and then justify that you can use your answers in A and B to draw the graph. Okay. Steps to graph it. I'm going to first put my zeros, put the x-intercepts, right? Mark the x-intercepts. After my x-intercepts, then I'm going to mark where the vertex is. So I know that's going to be the bottom of my graph. It's going to be the lowest point. In this case, the minimum. And then I'm going to go ahead and find the y-intercept because I need to know when it's going to cross the y. And we can do that by, think about it, when you're on the y-axis, what's the value of x? Well, that's when the x equals 0. Because if x equaled a number, it would move off of the y-axis. So when x equals 0. So 0 squared is 0. Negative 4 times 0 is 0. Minus 12. The y-intercept is negative 12. So then, to justify this, I'm going to take some graph paper, which I need to reprint that. That's really light. You can barely see the graph there. And I'll say, this is how I would graph that. And I would list these steps. First, I would put the zeros, and I found my zeros at negative 2 and 6. So I'd go negative 1, negative 2, and then 1, 2, 3, 4, 5, 6. It's hard for you to see that, but that is 2 and 6, negative 2 and 6. My y-intercept, I said, was at negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's my y-intercept. And then the vertex was at 2, negative 16. 1, 2, and this is negative 12, 13, 14, 15, 16. Right there is my vertex. 2, negative 16. Okay, so after taking all of those, knowing this is a minimum, knowing all of my intercepts, I can just draw the graph now. I know it's not going to go lower than that. That's going to be where it turns around. It's going to cross the y, going to cross the x, and that's it. We've graphed it by just taking the intercepts and the vertex, and that's all we really need to know. The rest of that, it'll fill in itself. As long as we make a U shape, crossing through those points, that's as accurate as we're looking for on graphing this. You could go to Desmos, put that in, and it should look exactly like that. Or really close. Maybe my arrows are a little straighter or something on there, but this is what we want to know. Can you graph a quadratic by hand without having to make an XY table, right? Well, if x is negative 1, then I put the point here. If it's 0, I put the point here. If it's 1, I put the point here. If it's 2, put. No, we don't have to make a table. We can just use those key points that we find from our quadratic equation and be able to graph it just like that. And that is part C. That is it. That is the 3 questions that's going to be on part 2. You'll have different formulas, of course, but that is the things we're looking at with those type of things. With the factoring primarily, being able to factor. You can do a lot when you can factor a trinomial there. So I will be posting this video. I've been recording this so that way you can go back and review this before you take part 2 of the test if you like. You can go back and review this. I will also have the practice test that I take the practice test. I will be posting that. That will be online. So before you take part 1 with all the multiple choice, you might want to watch me take the practice test, because the practice test, really, if you're not doing well in the practice test, you're not ready for the test, right? Because it's the same type of problems. The practice test gives you more problems of the same type of problems you have on part 1. So if you take the practice test and score like a 28%, why do you take the test right after that? You shouldn't take the test right after that. You should go back and say, what did I miss? Oh, I didn't do that right. How do I do that? That says it's from lesson 802. So let me go back and look at lesson 802. Oh, I forgot that step. Okay, now I know how to do that. So maybe I want to take the practice test again to make sure I do know how to do that. Okay, I got it right this time. I understand. Good. Now I'm ready to take the test. And now I can take the test because the test counts. The practice test doesn't count. Test counts. I want to do well in the test and quizzes. 70% of your grade. So you want to do well in those parts. So if you do that, you take the practice test, you score that 28% or something. Doesn't affect your grade, yay. But it just tells you what you need to understand before you take the test. And if you can't figure it out from the lesson, you look at it and you're like, okay, that doesn't make any sense to me. Then you go, hey, Mr. Brock, I need to get with you because I looked at number 3 on the practice test and I still can't figure out how to do it. I went back and looked at the lesson. It doesn't make any sense to me. Can you help me with that? And I said, absolutely. And I will pull out my pen and paper and we will do some work together until you understand how to do number 3. Then when you take that test, you'll be able to just blow it away and do well. So use the practice test to your advantage. It's not just busy work. It's a chance for you to know what you don't know. Because if you bomb it on the practice test, you're not going to get it on the test either. Right? So understand the factoring and you'll be fine. Because really, that's what most of this is factoring. Next week, we're going to start our last unit, which is all quadratics. So quadratics are a big part of math. And so this is a good jump by understanding how to do quadratics now. That'll help you when you get to that.